Okay, thanks everyone for coming today. Let me introduce the chair of the host today, also the chairman of HAESCO, Mr. Colin Tam. Mr. Colin Tam is an entrepreneur with over 14 years experience in many industry, especially focused on energy industry. He's the founder and the chairman of Crystal Vision and also the HAESCO. Today, the organization of today. Let's welcome Mr. Colin Tam to start. Thank you.
Thank you, Ivan. As he mentioned, I'm very proud to be the monitor for today's seminar. First of all, on behalf of HAESCO, it is my honor and pleasure to welcome you all to the second 2021 seminar of the HAESCO OSI Energy Efficiency Forum. We have people both physically in the room here, as well as people that are online. I particularly want to thank those who stay up late in the evening in the US to attend our seminar from America. I hope that all attendants will find today's topics worth their while. Before I go any further, I would like to introduce our founding and now honorable chairman of HAESCO, Mr. Dominic Yang, who's also here today. I would also recognize our vice chairman, Patrick Yang, our honorable treasurer, Professor Simon Chang, and our honorable secretary, Dr. Ivan Lee, who did the introduction just now, and also my fellow board members. Without them, we will not be able to carry on with what we have been doing, the many events for the last 2-3 years. For the last 3-4 years, we conducted at least 4 professional seminars, also an annual conference. Plus, we also participated in 2 major environmental conferences in Macau and Hong Kong. In fact, today is the last day of the MIECF conference in Macau. HAESCO originally would have a physical booth there to represent our members. But due to COVID, that have been canceled. However, HAESCO still have a online booth, and one of HAESCO's member were making use our virtual booth to introduce their new technology and products for China. So if you fee after this seminar, you can maybe still try to catch the last half date of the MIECF conference. HAESCO will be participating at the Eco Expo Asia in October this year, 27th to 30th October, later this year. Hopefully, COVID would allow at least some of us to be at the convention center. We will be also working together with 3 other co-organizers on a half-a-day conference on hydrogen, which will be the second hydrogen event very successfully done a year ago, where we have several hundred people register for that event. So we would try to hope to see Eco Expo can also be able to conduct both physically and online. And if you were HAESCO members and want to participate or want to find out how the event can help you, please let us know. HAESCO was founded on 12 January 2008, more than a decade ago. It is the first Hong Kong energy efficient service association. HAESCO aims to bring blue skies back to Hong Kong by saving energy, which is a topic that's so important in the new decarbonization pathway that all of us in the world will try to follow. Many of the current HAESCO members also involved in renewable energy, digitization of energy industry, energy efficiency, and climate change, which is the topic of today's seminar. The seminar is funded by the Clean Production Partnership Program, CPPP, of the Hong Kong Productivity Council. Topic of the discussion for today is in what way the low carbon 2050 target affects the manufacturing industry. The Hong Kong Polytechnic University is the co-organizer of this event, as well as the one that providing the physical venue for our seminars. Supporting organizations include Hong Kong IE Gas and Energy Division, the Institute of Mechanical Engineers, IPPF, IEEE, PSPES, PELS, IES, and IAS, as well as the Hong Kong Environmental Industry Association, the Hong Kong Green Strategy Alliances, the Hong Kong Fuel Cell and Hydrogen Energy Association, and also the Business Environmental Council. Now let's start. The first speech will be by Dr. Mandy Fan Meng, who is an assistant professor at City University of Hong Kong School of Law. Dr. Fan held postdoctoral fellowship at Chinese University of Hong Kong and the National University of Singapore. She obtained her PhD from City University, her LLM from University College London, and Bachelor of Management and Bachelor of Law degrees from Chongqing University. Her research interests include international economic law, World Trade Organization law, and energy law. Her research appeared in peer-reviewed journals as the Journal of the World Trade, Journal of World Investment and Trade, Chinese Journal of Environmental Law, and Climate Law. Her work also appeared in edited collections published by the Cambridge University Press, Routledge, and Springer. And her topic for today will be impacts of international trade regulation on the China solar PV and the new energy vehicles industry. I couldn't think of a more important topic that we are facing today, especially given the current status of the American-Chinese relationship. Without further ado, Dr. Fang.
Let me try the clicker. Oh, sorry. Good morning, everyone, and good evening to those who are not in Hong Kong and wherever you are. And thank you very much, Chairman, for your very kind introduction. And thank you for the invitation. It's truly my great pleasure to be here with all of you today for this panel and this discussion. I can remember when last time I attended an offline conference. It must be more than 1 year ago. So it's truly great to be here this morning with all of you. And today my topic is international trade regulation and China's solar PV and new energy vehicles and EV industry development. So I would like to give a comprehensive analysis of the interface between China's solar PV and NEV policy measures and international trade regulation, namely the World Trade Organization rules, the WTO rules. And the outline of my today's presentation, as you can see, is I will start introducing China's rise in these two sectors with a discussion of the supportive policy measures used by China that will have trade implications. Then I will move to the second part that is about the international trade regulation, the WTO rules. What is this multilateral trading system? What are the rules? What is the jurisprudence? And the trade disputes so far have been brought under this regime concerning the clean energy, including solar PV. Right now, we don't have any dispute brought against the NEV, but we will focus on the solar PV sector for this part. And then in the end, I will make some policy recommendations, such as how to achieve industrial upgrading without violating China's WTO commitments. So those basically today's outline of my talk. And I think it's quite important because right now with China's 2030 and 2060 climate commitments, the carbon neutrality, China is certainly poised to drive up its manufacturing capacity in clean energy sectors. And as you know, solar PV has always been one of the strongest manufacturing sector in China. So we are quite confident that in the future, it will continue to grow in this sector. And NEV is more like a latecomer, but still is really scaling up at the current stage. So those are the two sectors in today's focus. And I would like to first start with the discussion of the solar PV and NEV sector in China. I want to, before I move to discussing the specific measures, I want to present to you the growth China has achieved over the past decade, over the past years in those two sectors. First, let's look at the solar PV manufacturing. The capacity surge from 2006 to 2017, as you can see to your left hand, the share of Chinese solar panel production globally rose from 14.7, that is below 15%, to now it's more than 70%. So that is more than 3 times growth in just 1 decade's time. And to your right hand, that shows the global top 10 solar module manufacturing firms. And China took, again, the majority of them. Like those are the Chinese manufacturing firms that have been scaling up really, really quickly over the past 1 decade. So right now, China dominates the largest share of the global solar PV manufacturing, not only just the assembled panels, but also like modules, cells. Chinese solar firms have been also very, very competitive. So that is about the solar. Now let's look at the The other one is China's new energy vehicles. As I earlier mentioned, this sector started to develop at a later stage to the solar PV sector. Therefore, the growth only started to take off in the mid of 2010s. So that is from 2013 to 2014 actually was a defining moment for the taking off of the NEV manufacturing. I will explain that later, why that year became the defining time. But as you can see, from 2015 to 2019, the sales of the, I think it's covered by that bar, but it's fine. The sales of the electric vehicles and the production of electric vehicles in China experienced a 3 times growth in just 4 years time, in just, 5 years time span. The growth rate is incredibly fast. And then you can see when you compare China with the other markets in the other parts of the world, China also has done an amazing job. To your right-hand side, the bottom is a comparison between China and Europe and the US. So right now, China is the world's 2nd largest NEV market. Actually, it overtook the US in 2015 to become the world's largest market. But in last year, the EU then surpassed China to become the world's largest NEV market. But some commentators predict that China will soon regain its world's largest NEV market status soon, because 2020 is quite a turbulent year for China and the depressed demand from consumers. So those elements contributed to a declining demand of the domestic market for the NEVs. But people are still quite optimistic about the future prospect of the NEV market in China. And to your left hand side is a graph showing you the electric vehicle sales in China, which models, which brands are popular. So although Tesla certainly is the most popular one, but you can find those homegrown, Chinese homegrown brands are not doing bad. They are doing pretty well, like BYD and a few like the so-called new forces, like Lixiang, NIO, and Xiaopeng. Their sales have been growing quite quickly in the recent 2 years. And then the rest would be the joint ventures between Chinese companies and foreign brands. So those products have dominated the Chinese NEV market. Although Tesla is the biggest one, that's certainly certainly right. But Chinese homegrown brands are also catching up, and we will expect those new forces, the 3 brands like NIO, Xiaopeng, and Lixiang are going to catch up in the coming years. So witnessing this drastic increase of manufacturing capacity in 2 sectors, a following question to ask is, how could this happen? So what is the motivation and what are the driving forces for this incredible increase of manufacturing capacity in those 2 sectors for solar PV, for NEV? So I would argue there are a wide range of measures that have played very important role in driving up this manufacturing capacity. And due to the diversity of those measures, I would like to divide them into 2 big groups. One is border measures. The other is behind the border measures. And those measures also can have implications on international trade, meaning that they either could promote international trade or they could restrict international trade. So because today's topic is related to international trade regulation, so I would only focus on those measures that can implicate international trade, that I will not look at those measures that are neutral in international trade. So for border measures that China have put in place to support its own domestic manufacturing are those like tariff and quota. So those are the 2 measures that can be imposed on the border during the exportation or importation of goods. And tariff is easy to understand. And earlier, our chairman mentioned the US-China trade war. And after the US-China trade war, those products coming from the US to China now have to face a higher tariff. And as a consequence, the Chinese competitors, they would enjoy this protection because their competitors from the US have to pay a higher tariff. So their products will be disadvantaged to some extent. But as a developing country, China is permitted by the WTO to maintain a relatively high tariff rate over those years when compared to the US, to the EU. China's tariff is actually quite high. For the vehicle sector, for a long time, it's 25%. Well, if you look at the US, it's below 5%. So this is a huge difference. With this high tariff in place, the domestic manufacturers certainly can enjoy the benefit. They can, because the price of those imported products will be artificially driven up. So that gives one layer of protection. And besides from tariff, there is another type of border measures that tend to be overlooked, but in my argument, it's also very important, is a quantitative restriction, that is a quota. Unlike tariff, which is widely used when you import stuff, quota has been increasingly used by Chinese authorities when they export stuff outside, such as raw materials, like rare earths, like those minerals. And those rare earths, raw materials, they are critical inputs in the manufacturing of those clean energy products like solar panels, wind turbines, and the batteries to NEVs. So by imposing this quota, the quantitative restriction on raw materials, the consequence would be foreign producers that rely on Chinese raw materials now cannot get the raw materials, or they have to pay a much higher price for the same raw materials. So that will drive up their cost. Whereas for manufacturers in China, they still can have access to a stable and cheap supply of those raw materials. In this sense, this will give another layer of protection to Chinese domestic clean energy manufacturers. However, those kind of measures has been lamented by Chinese, by China's trading partners, and China put it in place for years and then remove it and then put it back in place again and then remove it. So we have witnessed in the past decade of this frequent frequent recourse to these quantitative restrictions on those critically important raw materials that serves as an input to those low carbon technologies. So that is the second type of border measure that is certainly has trade implications and also can protect Chinese domestic solar PV and NEV manufacturing. So besides from the border measures, the second group is the much broader behind the border measures. So the scope of this is certainly wider, as you can see, measures like tax, subsidy, regulatory measures, technical standards, technology transfer, investment related measures. All of these measures can be categorized as a behind the border measures because those are imposed when the foreign products clear the custom, enter the territory. So that's why they are called the behind the border measures. And the WTO, the international trade regime, also have rules disciplining the use of those measures. I will get into that very soon, like what the WTO says about it. But now I want to introduce to you some pervasively used behind the border measures to support Chinese solar PV and NEV manufacturing sectors. So for tax, for instance, the Chinese government has been quite enthusiastic to provide tax incentives like tax exemptions, tax rebates for clean energy firms. If they could qualify, if they could meet certain requirements, they can get a reduction for their enterprise income tax or for other types of tax. So these tax incentives have become increasingly used by Chinese authorities to incentivize clean energy technology firms to innovate, to produce, to export. So that is about the tax measures. And the second one, which I argue the most controversial one, is a subsidy. And I'm sure all of you have heard about those allegations made by China's trading partners against China for illegally using subsidies to subsidize its own at the cost of its competitors. So subsidy by itself is a very controversial issue, and WTO has a single agreement to govern the use of subsidies. And subsidy can take quite a variety of forms, such as a direct transfer of funds, the equity injection, the cheap land and electricity, or even free land given to those manufacturing firms. So among those various forms of measures, not just the central government is using it, also local governments in China have increasingly recourse to various forms of subsidies to attract those manufacturing firms to set up either manufacturing plants or headquarters in their localities. And just a few days ago, I read a news about how much money Xiaopeng NEV manufacturing got from Wuhan government and from Guangzhou government to set up a manufacturing plants in those localities. So you can see this pervasive use of subsidies by Chinese local governments, and those can certainly contribute to the scaling up of the manufacturing capacity of those firms. And besides from tax subsidy, we also have the regulatory measures that is not as pervasively used as the other two, but still it can play a very important part, such as, let me give you an example. If a local government hands free license plates for new energy vehicles, okay, but only give those free license plates to domestically made NEVs, then what will the consumer do? The consumers will only choose the domestically made new energy vehicles instead of the foreign, instead of the imported one, because they want the free license plates. In cities like Shanghai, a license plate can cost as high as 80,000 RMB. So this measure can also play an incredibly important role in protecting domestic manufacturing firms. And besides from regulatory measures, we also have technical standards, technology transfer. That's also a term I'm sure all of you have heard about in the past about the forced technology transfer or technology theft. I will not delve into that too much today. And then the last one is investment related measures. This is a measure not just used by China, but also by many other countries in the world to help their own, to nurture their own infant industries. So overall, those are the measures I believe can explain the miraculous growth of the solar PV and NEV manufacturing in China. So after presenting you all these measures, now let's take a look at how China's trading partners react to China's use of those measures, either border measures or behind the border measures. Those are not, this is not an exclusive list for sure. I just quote a few from the government reports either produced by the US or produced by the EU. So now let's take a quick look at what their allegations are. So the first two are related to the new energy vehicle sector in China. The USTR, the United States Trade Representative report to Congress in 2019 pointed out that Chinese NEV industry has China has pursued related policies apparently designed to promote the development of a Chinese NEV industry at the expense of foreign enterprises. So how to understand at the expense of foreign enterprises? I will explain that later. And then 2017, the European Union also published a report criticizing the central and the local governments in China supporting the domestic NEV industry that often lack strong technological capacity. So this favorable treatment to domestic industries, that is another criticism that European Union gave to China. Besides from those two, in the NEV sector, we also have witnessed much more criticism given to the solar PV sector. And how so? As I earlier explained, the solar PV took off at an early stage than the NEV. So in China, the solar PVs, the maturity of solar PV technology is higher than NEV. In other words, Chinese solar PV firms at current stage are more globally competitive. Therefore, inevitably, they would attract more criticism and also countermeasures. And now let's take a look at what the solar PV sector has to deal with. So for instance, 2018, the USTR, again, the United States Trade Representative, in investigating the Section 201 cases and pointed out that China's industrial planning has included a focus on increasing Chinese capacity and production of solar cells and modules using state incentives, subsidies, and tariffs to dominate the global supply chain. Therefore, after their investigation, they very quickly put in place the increase of tariffs against solar panels exported from China to the US after this investigation. And 5 years earlier, 2013, European Commission also released a report criticizing Chinese companies selling solar panels in the EU at far below their normal market prices. So that is illegal dumping. And besides from that, they also pointed out that those firms received illegal subsidies and causing significant harm to the EU solar panel producers. Besides from the EU and besides from the European Commission price release, before that, the US also had the, I don't think it's, okay, it's fine. I think the PowerPoint is not demonstrated in its entirety, but it's fine. I can read it to you from my own slides. So in 2012, the US ITC, the International Trade Commission, pointed out that the Chinese solar cells were sold at less than fair value in the US market and subsidized by the government of China. It's basically like anchoring what the European, it's basically what the European Commission anchoring 1 year later. It's like there is these subsidies, illegal subsidies and dumping. So those are the those are the reactions of China's trading partners to China's miraculous growth of the solar PV and NEV manufacturing capacity. So now a following question we would like to ask is this true? What they are saying is true or not true, or it's just malicious allegations, or there is some truth in it? And here we need to bring in the WTO here because. So now I would like to give you some introduction to this World Trade Organization that constitutes the international trade regulation. So this WTO is the only multilateral trading system in the world. Although we have numerous bilateral trade agreements, regional trade agreements, but when we talk about the multilateral one, we only have WTO. So that is why it matters. And a lot of those trade remedies, as I earlier demonstrated to you, also took place under the WTO, and the trade disputes also were brought to the WTO, not to other like bilateral trade agreements or regional trade agreements. That's why we need to look at the rules under the WTO. We need to apply the relevant WTO rules to China's policy measures, and then analyze whether there is this incompatibility or or Chinese measures are simply consistent with the rules. It's trading partners' simple protectionism to retaliate against China. So WTO, what is WTO and the membership? I think it's very easy to understand now. It's 164 members and covering almost 100% of the world trade, world GDP, and world population. And WTO governs not just trade in goods, but also trade in services, trade in intellectual property, and also investment-related measures. But for today's talk, I will just focus on the most fundamental ones and the most relevant ones. Otherwise, I will simply not have time to cover everything. And the WTO functions implementation of trade agreements. And under the WTO, there are different trade agreements that can covering trade in agriculture, trade in sanitary, phytosanitary area, trade in IP, trade in goods. So it's really diverse and broad. But to today's topic, the most relevant one would be the subsidy agreement, the anti-dumping agreement, and also the general agreement on tariffs and trade. So those three agreements matter, I would argue, the most to the development of clean technologies in China and other parts of the world. And I will explain that very soon. Besides from the implementation of trade agreements, WTO has a few other functions that are equally important, such as a negotiation of the new trade rules. Although this function is kind of in a coma right now, because no agreement has been achieved in the past 1 decade to put in place a new agreement. And besides from negotiation function, we also have dispute settlement. This is incredibly important because when WTO members, they bring trade disputes against each other, they would bring it to the WTO dispute settlement body and let the judges, the WTO judges, to make adjudication, to decide if any side is wrong, if any side is illegally is violating its WTO commitments. Besides from dispute settlement, the fourth function is the trade policy review. That's not very relevant to my today's talk. And earlier I mentioned there are a lot of agreements under the WTO, and I simply do not have time to cover them, but I feel like it's still very important to demonstrate those basic funding principles under the WTO to give you some idea about what the WTO aims at, what are the objectives. So here, the principle number 1 is non-discrimination, only with limited exceptions. Under non-discrimination, there are 2 pillar stones. One is national treatment, which means treating foreigners as if you own. So that is one of the cornerstones of the WTO, is to grant national treatment to foreign producers. When foreign producers need to compete with your own, you can discriminate against them. You can deliberately favor your own at the price of the foreign producers. Besides from national treatment, another pillar to the non-discrimination is the most favored nation, MFN, which means you have to treat all your foreigners equally. You can't just treat your strategic allies better than other countries that you don't feel you have any strategic interest to share with. So once you join the WTO, you have to treat all of other WTO members in the same and equal way without favoring one over another. So that is a non-discrimination principle. Besides from non-discrimination, the WTO also has been advocating for the reduction of trade barriers. It could be for the tariff barriers or non-tariff barriers. After reduction of trade barriers is something that China's trading partners have always advocated for China to achieve in these sectors, like for China to reduce the tariffs, for China to remove those onerous performance requirements imposed on foreign producers. So for the reduction of trade barriers, I will link to this later on in the later part of my talk. This is also very important for the dissemination of the low carbon energy technologies. And also it can show how the WTO can play a positive role in disseminate the low carbon, the clean energy technologies at a lower cost to make it more affordable. So that is what the WTO can play a positive role. So besides from those 2 principles, WTO also has been advocating the following 3 principles. One is predictability and stability through binding trade commitments. So once you commit yourself to certain obligations, to certain commitments, you should honor it. You shouldn't break it. You shouldn't eat your own promises. But now with the US-China trade war going on, I think it's undeniable that both sides are compromising their own commitments. They are not honoring their commitments in whatever way. The 4th principle is about fair and undistorted competition. That also is closely related to non-discrimination, to national treatment, right? If you favor your own over foreign counterparts, then you're distorting the competition. You're not creating a level playing ground. You're not shaping an enabling environment for foreign producers. And the last one is more beneficial treatment for developing countries. So those are the 5 funding principles of the WTO, and you can find all of those principles are enshrined in the WTO agreements. So after talking about those principles, now let's move to the disputes. Okay, after the rules, now we get to the jurisprudence. What the WTO disputes have been doing, what the dispute settlement body have been doing in adjudicating disputes that have been brought under the WTO. And here I presented a list of those disputes filed by WTO members against another in the renewable energy sector. As you can see, solar PV has certainly been one of the most litigious area, which means a lot of those renewable energy disputes are brought against solar PV, are brought in the solar PV sector. And why this area has been so has attracted so many trade disputes. One of the reasons is because solar PV has been traded internationally so frequently, like it's a highly tradable products, right? Once you have those international trade across borders, you are bound to have those conflicts, you're bound to have those trade disputes. Whereas so far, we do not have any NEV dispute brought to the WTO, but we cannot underestimate the probability in the near future that there might be some WTO member to bring dispute in the NEV sector. But now let's look at what we have is all of those disputes. So I will not go into the details of them because that would be quite boring, but I want to highlight 2 points. One is if you look at those complainants and respondents, like United States, India, European Union, Canada, United States, again, China, Japan, all of them are major renewable energy producers in the world. I would argue that actually they are the biggest one. They constitute the majority of the global production in the renewable energy sector. Therefore, this competition is so fierce, is so intensified. So that explains why they are eager to bring the disputes against each other under the WTO, prevailing in the disputes, so that the losing party has to change their trade practices. They have to bring their measures into compliance. So that is how the WTO dispute settlement works. And besides from the fact that all of those major producers are so eager to bring disputes, the second one I want to bring to your attention is that one of the commonalities shared by all these disputes is that the measure at issue is one commonly used measure, is that every dispute concerned the same measure, that is a local content requirements. I'm sure some of you, you are familiar with this measure. So local content requirements, this is a very, I would argue, very previously used measure in developing the renewable energy manufacturing, not just in solar, in NEV, but also in wind, in biomass. You can find the existence of local content requirements so pervasive. And all of those disputes concern the use of local content requirements. Some might concern a few other issues, but at least all of them have one measure at issue in common, that is the local content requirements. And in the end, the WTO judges, the WTO panels and the appellate bodies, all of them in each and every dispute ruled against the use of local content requirements. I understand that some political economics and some economics argue that local content requirements can be conducive, can be helpful in obtaining political support for renewable energy. Therefore, it should be allowed to exist, should be allowed to be, like the WTO should not restrict the policy space for these kind of policy measures. But in my perspective, the local content requirements, and I think trade lawyers, a lot of them also think the same way, that local content requirements are ostensibly discriminatory measures. You ask, such as in China's case, I will use as an example is China, the one brought by the United States against China, measures concerning the wind power equipment. I remember in that case, the local content requirements have been mandated by Chinese authorities on renewable energy power generators, which means those renewable energy power generators have to only purchase domestically manufactured wind turbines in order to get subsidies. So this type of local content requirements will restrict access for foreign producers and enable the access to your own. Therefore, it can distort the market. It can distort the trade. It will disadvantage foreign competitors. But let's not forget that the WTO, one of the principles is national treatment, is non-discrimination. So therefore, China in this dispute after the United States litigated against it, China removed this measure in the end eventually. So that is quite amicable result between the United States and China. But right now, is China still using local content requirements? Actually, yes. In the NEV sector, China also put in place the local content requirements to support its battery manufacturing firms. But right now, China removed that after 5 years, putting that measure in place in the battery manufacturing sector to help this battery manufacturing, the battery powers, the batteries that powers the NEVs. But China removed that before any WTO member had a chance to litigate against China. So 5 years, China removed it. Again, I mean, this WTO dispute provides you some give you some understanding about what the WTO advocates for and what the WTO rules can, how WTO rules can play in the member states' development of these low carbon energy technologies. So besides from those multilateral disputes that you can bring under the WTO, there is another set of retaliations, another set of countermeasures WTO members can use is the so-called trade remedies. So this is going to be end of my presentation. Okay, sure. Yeah, I can finish in time. So trade remedies is another set of countermeasures WTO members are allowed to make against each other. And here, Chinese solar PV producers have suffered really a lot of those trade remedies imposed by its trading partners. Just give you, as presented in these slides, EU, India, US, Canada, which used to be Chinese solar producers' largest export destinations, they imposed various forms of trade remedies against Chinese solar PV export. Against Chinese solar PV exports, it could be anti-dumping or countervailing duties or safeguards. And in some cases, this tariff rate can increase to as high as 120%. So Chinese solar PV exporters, when they export their products to the EU, they have to pay 120% tariff because of the anti-dumping or countervailing duties imposed on it. And then why this happened? I'm not arguing that China necessarily did something wrong, but my point here is that we have the trade rules, and those trade rules create policy space for its trading members to take measures to their own hands. So they could impose those tariffs under either safeguards, anti-dumping, or countervailing duties against Chinese PV, or perhaps in the future NEV, we don't know, right? But right now, we have encountered so many cases, like the Chinese solar PV exporters encountered so much opposition from its trading partners. So in light of these trade frictions, in light of these trade tensions, here I would like to move to my conclusion part, is what China can do in the future to drive up its industrial upgrading without violating its trade commitments. Otherwise, you know, those countries can litigate against China at the WTO, or they could use unilateral measures to restrict Chinese exporters. So it could both be possible. Therefore, it's very important to bear in mind those trade commitments, those trade rules. So by taking into consideration the WTO jurisprudence and the WTO rules, I would like to make following recommendations. The first, what China can do is gradually reduce its own tariffs on low carbon technologies. After all, its trading partners have been frequently criticizing China for still instituting such high tariffs as barriers. Okay, and then the second one, China also needs to remove ostensibly discriminatory measures, like earlier the white list in the battery manufacturing sector. That is certainly a breach of China's WTO obligations, but thankfully China removed it before anyone could bring a dispute against China as a WTO. Otherwise, it will face besides from reputation loss and also the trade retaliation possibly. And then it's also important for China to avoid prohibited subsidies. The prohibited subsidy within the meaning of the SCM agreement, the subsidy agreement under the WTO. If you can avoid prohibited subsidies, you can lower the chance that your products will be subject to the so-called countervailing duties that your trading partners can impose on you if they identify any prohibited subsidies. Therefore, the third recommendation is about to remove those subsidies. Otherwise, you just give excuses to you just give opportunities, hand those opportunities to your trading partners to retaliate against you, to impose those trade restrictions. And the fourth one is related to the second one, but the fourth one is from the procedural aspect, is that China should fulfill its subsidy notification requirement as required by the WTO. I know right now, like this subsidy notification is not very well done by WTO members, but I think China could play a positive role in being more, in ensuring the transparency and fulfill its notification requirements. And then the following two recommendations is from also a geopolitical and a strategic perspective, is to diversify its export destinations, like the lessons taught from those trade tensions in the solar PV sector. China has been too heavily reliant on a limited amount of export destinations like in the US, in the EU, so that invites countermeasures, and that creates very risky paths for China's solar PV makers in the past years, is that they were very desperate to diversify their export destinations once those EU and the US authorities imposed the hefty tariffs on Chinese solar PV exports. So to diversify the destination, reduce the risk, and the meantime to explore and expand the domestic market potential. This is also a reason why the NEV sector hasn't attracted so much criticism, or hasn't, no single trade remedy measure has been imposed on Chinese NEV. Besides from the NEV is relatively at a young stage, the other important reason I would argue is that right now, the majority of Chinese NEV production is absorbed by its own domestic market, unlike in the solar PV case, is so reliant on the exports. So once you produce, you export, so that you drive the competitors to bankruptcy in their own markets. So that can easily invite criticism, and that can easily invite the trade countermeasures. But here, rely more on your own domestic market that will reduce the risk. That also corresponds with the current dual circulation proposed by Chinese President Xi Jinping, right? So that is give more emphasis on your own domestic market to create untapped to exploit the untapped potential in the domestic market. Again, I believe that with 2030, 2060 carbon neutrality targets, and also in the post-pandemic era with countries aiming at green recovery, building back greener, building back better, there are huge opportunities for Chinese clean energy technology firms to take, for them to increase their market share, for them to scale up their manufacturing capacity, for them to boost their R&D capacity. But at the same time, I also want to remind there are outstanding challenges for Chinese clean energy technology firms, not just the US-China trade war, but also now you can see the trade tensions with India, with the EU, with Australia. So all of those are the outstanding challenges that China cannot turn a blind eye to. Therefore, it's very important to bear in mind the international trade commitments, international trade rules, when Chinese authorities design and implement policy measures to drive up its own, to develop its own industries, to develop its own market. Always remember those international trade commitments and play the game by the rule. So that is what I want to share. I hope I don't have too much time. Thank you very much.
Our speaker will be engineer Javier Yip. Mr. Yip graduated from the Hong Kong University of Science and Technology. Hold on a second. Yeah, I have some technical difficulty of my own here by having my Zoom on. So Mr. Yip is graduated from the Hong Kong University of Science and Technology in 2006. That sounds so young to me. And with a bachelor degree in chemical engineering and the University of Nottingham in year 2012 with a master degree in energy conversion and management. He is currently a project officer by contract in the electrical and mechanical services department of the Hong Kong government, which we normally call EMSD. His primary responsibility will be involved in managing innovation and technology projects related to EMSDs within the premises of the Hong Kong government departments, i.e. that they are EMSD is responsible as the facility managers for all the Hong Kong government properties, actually. So that's a very big job. Prior to working in the government, Javier has successfully been a process engineer for 5 years, serving the manufacturing industry of electronic and solar PV cells, and an engineering consultant employed by world-renowned company like Arup for 6 other years focuses on building sustainability and renewable energy projects. He has assisted a number of US and China manufacturer of solar PV cells, including SunPower, I believe is listed in the US, and Alter Device. So and his topic for today will be towards self-sustainable, cost-effective market in Hong Kong. Watch out of facilities in design, operation, and maintenance. I couldn't wait to hear on these topics. So without further ado, I yield the floor to Engineer Yip.
Thank you, Chairman Colin, for the high praise. And thank HAESCO for having me here today. Good day, everyone, here and on Zoom. Right. First off, a bit of disclaimer here. I do not speak for the government today. It's just a very personal sharing of my own experience and opinions in the industry. So please do not construe anything of my thoughts and saying as something from the government. So on this slide, on seeing the 2 videos on your left-hand side, what comes to your mind about them? They are very high precision in manufacturing. Usually the manufacturers invest quite a lot, in fact, billion of dollars in building quite the size of the factory like these. And sorry. And they also For example, the cell testing and sorting machines here at the bottom left-hand corner, they each of these machine costs about $100,000 well, about a decade ago, and they put each of them or several of them on a full scale on a full production line. So as you can see, they invest quite a lot in the pursuit of product quality and talking about the differentiation of product qualities into just merely one decimal place in percentage of the solar conversion efficiency. Compared to the two photos on the right-hand side, these are the applications right now in Hong Kong. They are, in fact, due to very low awareness in the design and construction, causing the PV systems not to function very well. As you can see, some PV panels blocked by, shadowed by the parapets on the main roof, and even shadowed by the PV system itself. So you may say in Hong Kong, it is the site constraints or the limit of space plays a part in the Hong Kong, limiting the application of PV, but it is largely due to the practitioners in the industry as to whether or not they have a very sensible mind in designing, constructing, and even operating and maintaining the systems properly. So some of the practitioners in Hong Kong may overly rely on the power electronics like microinverters or power optimizers to help salvage some of the electricity generated by these inferior PV panels, but it would jack up the capex as well as the opex. So it definitely requires them to have a more thorough and sustainable peace of mind in the project run. So agenda of my talk today. I'm afraid I may seriously overrun the talk if I really go through all of them, but I would put more emphasis on the case sharing later on, as well as some of the issues that I want you to be more aware of, especially the financial analysis from the perspectives of project owners, investors, like you guys in the floor. So I will not go through all of the physics, science, fundamentals of the previous year, which you may have learned a lot from the academia or any technical talks elsewhere. Right. First of all, the feed-in tariff policies in Hong Kong, it is of gross nature. So what is generated out of the PV system on your rooftop, residential rooftop, for example, would directly fed into the main grid without any part of it consumed by your household appliances. So all out, all in. So you still have to pay for what you consume with your household appliances in the end. And the current subsidy scheme will run until the end of 2033 by 3 of the classes of subsidy. As for the feasibility study, it is utterly important because you can know how much you would invest in the project, whether it is financially viable or technically viable. So first off, you draw out an analysis like this by analyzing, for example, net present value, NPV, internal rate of return, simple payback, discounted payback. So through this study, you at least understand the overall cost of green contributions by investigating the properties, the performances of the products. And then in the end, you would come up with an overall picture of the system performance over the whole course of, say, 25 or 30 years, or even 40 years beyond, I have seen in some of the cases. So over the whole course of the lifespan. But in the meantime, you should also keep in check the causes of sun shadowing, be it the environmental light, soiling factor light, this one at the bottom, at the upper right-hand corner. Geographical or geometrical obstructions. And even worse of all, some man-made errors or malpractice of the project design team or construction team. And then after knowing the intrinsic, sun shadowing effect, you should start off with some simulation tools. So there are quite a number of them, like PVSYST, which is a proprietary product, and also some other free of license like Solar Edge, Red Screen, PV Walls, most of them, you can name it. So these simulation tools starts with a building modeler, and you can put all the intended number of solar PV panels at your preferred locations. Then they run the simulation based on the given set of climatic data for the region or city. And then it will plot out the annualized performance of the PV system on a monthly basis. So two of the gauging parameters that you may have to know is the performance ratio here. So for a good system, PV system, at least 70-something% or more, or with a specific production or the energy density of at least 900 kilowatts per kilowatt peak per year. So these two gauging parameters would help you to differentiate whether the system is good or not, or profitable or not. And most of these simulation tools also come with the massive database of the electrical equipment. For example, in PVSYST, they have a very powerful library of all those electrical devices, accessories, so they can take into all of the, for example, the conversion efficiencies, the electrical losses down along the cables. So many of these factors into the simulation. But there is also a drawback with these simulations tools because most of them have their very simple, very raw, very primitive building modelers that you can only construct a very simple building form of your subject building. If you try to include quite a area of the laboring environment, usually these systems would be stuck. So it's better to do a separate study of your sun, for example, sun shadowing effect with other 3D drawing softwares like 3D AutoCAD, Revit, SketchUp, Rhinoceros with Radiance plugin, IES virtual environment, etc. To study the sun shadowing effect in particular into extreme conditions of these sunshine, which are the summer solstice and the winter solstice, so that you can get to know the maximum area of shadows cast by the surrounding obstructions onto the installation area. Then you can make your best effort to avoid your PV panels being cast by these shadows. But also you can also with these drawing tools or simulation tools, you can also study a wide variety of other shadowing factors. Another way or approach to the study of the sun shadow, which I've seen recently in Hong Kong by with some serious contractors, is the use of handheld, very localized measuring devices like somatic sunlight. So this device can be placed at the point at the time in the installation area with a camera view to see, well, at least to observe a whole day of the sun path with all those obstructions like trees or laboring rooftop building structures. And then it will predict the whole year's sun path, because the sun tracks, as we know, are constant all over the year. So the device will help to predict this the whole year's sun path based on that condition, and feed those data into the like of as PVSys. So this way could help to help the prediction, the simulation tool even better in a sense. And this slide is about the comparison between the conventional type of wafer-based crystalline silicon and some prevailing or burgeoning types of thin film technologies. I would not really go through all of them in detail, but I would like to say that although the current PV market does not go very well with the thin film technologies, at least not so well as predicted by the market at least a decade ago. But I would not deny the latest search of such applications in the future, especially it is of very high potential to be applied to the like of BIPV, for example, on this transparent glass, on very complex curved or structure, exterior structure outside. So this kind of thin film technology can have more flexibility for application. And besides, it is also lighter in weight, so it would not impose much structural challenge to the building. Okay. As for the installations, well, there are many international standards out there relevant to the PV systems. I will not mention all of them, but mostly they are from, for example, America, Germany, European, ISO, British standards, whatever, and even Guobiao in China. But in the case of Hong Kong, the whole procedure of review and submissions is fairly simple. You just have to do the submission about this, for example, about the window and structural safety to the buildings department, as well as those the whole system performance or electrical aspects to the two utility companies, CLP and Hong Kong Electric. And we are quite fortunate here that we also we also don't have to study the slow load because in some far north region in the world, they have to deal with the slow load as well. And the and for example, in this poor in this poor example in Hong Kong, actually, although there is a limit of the supporting concrete structure by the Hong Kong regulations like Cap 123, but in this case, the system can actually be raised up to the heights of the parapets here, which I believe is around 1.1 or 1.2 meters, usually found in the main roof of the buildings, because the current limits by the regulations is 1.5 meter. So at least in this case, the whole system can be raised up to this level to harness more solar irradiance without any sun shadows cast by the parapet here. But you may also say that the increase in the concrete content may jack up the cost of the investments, but still you can modify somehow the form and the volume of this concrete plinth, for example, to some numerous concrete blocks instead to support the structure and the pivot point. There are also two ways of mounting here in the market, like horizontal positioning or angle tilting. The angle tilting very much depends on the latitude, the longitude of your location or geographical location. For example, in Hong Kong, with the fixed installation, the best angle of tilting is 22.5 degrees because it lies between the 45 degrees in winter solstice and 0 or -5 degrees up north in summer solstice. So in between them, the 22.5 degrees would be most efficient way for an installation, for a fixed installation. But you may also look into the comparison between fixed mounting and auto rotation with sun tracking motorized system. But the latter ones is more demanding in terms of the land use and the separations, because the separations is talking about in all 360-degree directions. So you have to research much more space for that to avoid the sun shadows. And it is also, and this way is also more applicable to the case of like very high solar conversion efficiencies, solar cells or PV systems like concentrated PV, which with magnifying convex lenses to intensify solar irradiance by a factor of 100 to 500 something. So there is also a proposition that in the industry that somehow east-west side-by-side mounting could help increase your install capacity. But personally, I'm fairly skeptical of that, because this way is about the trade-off between the solar irradiance at noontime and the solar irradiance at in the morning and afternoon session. So with the east-west side-by-side mounting, you may get some more solar energy harvested in these two sessions, but in the end, you have to trade off a large portion of noontime solar irradiance, which is the strongest of the day. So I also did a bit of study of that with the case of Shanghai, a city around Shanghai. That's the with the 10 degrees east to west side-by-side tilting, I can get 1.5% more installed capacity, but in return, I would have minus 1.3% in the solar and in the quality of the production generation. So it's to me it's a meaningless way of adoption. And you also have to watch out the additional requirements from the insurance policy provider if you are going for example, utility scale projects, because these insurance providers will set some more requirements, particularly for the concern of fire safety. So they have more requirements on the access pathways, separations between the arrays, strings, but also requiring you to add more provisions of sensors like smoke sensors in case of fire occurrence. So you have to incorporate all these requirements in the system if you are opting for this scale of projects, and with your system insured by the insurance policy provider. So power electronics, there are two conventions in the design and operation, whether it is in string nature or in central nature. Each of them has pros and cons there. So it's very much down to your consideration as to whether you want to go for higher efficiency, but with more investments using the string units, or you opt for low efficiency, but also less investments with the central units. But I also have to mention that particularly the latter one has some more potential hazards with the very high DC current along the cables, because they are they can be more hazardous to the human users or to the operator if they are going to maintain the system. And this one, power optimizer, is a very recent invention because in the old days, without it, for example, in this case, at the upper right-hand corner, like this string number 2 here, in the old days, this underperforming string of panels would be entirely bypassed by diodes because they are underperforming with less power generated. But with the present more power optimizer, what it operates here is to, first of all, by keeping a constant voltage input required by the inverter, then the power optimizer tries to regulate both voltage and current generated from these 20 strings of modules, so that the resultant voltage all across these 20 strings will still meet the required input voltage, but the one generated from this inferior one is allowed to have a lower voltage, like in this case 19.2 volts compared to the 38.5 volts with the rest of the strings. So the current passing through all of them is adjusted to 13 amps instead of 8 amps or 6.5 amp out of these 20 strings of the modules. To my surprise, this kind of the power electronics has a longer lifespan with some of the brands available in the market, because usually they have only 10 to 15 years of life cycle, but with this one, they guarantee 25 years, so almost the entire life of the whole PV system. But you also have to watch out that there is a capping portion behind the operation of this power optimizers. So it is not applicable to all cases of with many more strings of PV panels underperforming. So the regular O&M practice for whatever size of your PV projects, you may want to install a microclimate station to record the climatic data, like the sun, the available solar energy all across the year, but also some SCADA monitoring network with control or something. But you also have to do some schedule checks on many aspects, especially after a typhoon in Hong Kong. Well, as for the cleaning of the PV system, there are several ways to do that. You can do it manually with a sweeper, or adopting a robotic cleaner here, like in this case, or using sprinkler type spraying a considerable amount of water down the panel. So with the burgeoning right, or with the burgeoning idea of the nanotechnology applications, there's also a brand new way to adopt this technology to the surface of the glass of the panel. So two ways available, which are the hydrophobic property or hydrophilic properties by altering the nature of the surface of the panels. So in the case of hydrophobic surface, where the water droplets or dust droplets has a very small contact angle lying on the surface of the panel. But this way would require a certain degree of tilting of your panels to ensure that all the dust and water droplets naturally run down to the floor. While on the other hand, the hydrophilic surface here, as you can see at the bottom right-hand corner here, the water is almost visually insignificant to the overall panel surface, and this way could be applied to the case of like horizontal panels lying on the roof. So case sharing in Hong Kong. This is a very recent personal encounter to me because I try to volunteer to offer my professional advice to the management, to the housing property management team of my current residence. They try to make a very good deal with the PV contractor, by installing a total of 60 kilowatts of PV installations. Well, each tower to bear 10 kilowatts of PV panels. That's the high hope. But I try to argue with them whether or not they should opt for this maximum potential, because this location, I don't want to review where it is in Hong Kong, but it's a very premium location with very minimal obstructions from other surrounding high-rise buildings in the region. But instead, they have some top roofs of different heights located on each tower. So what I'm trying to argue with them is to whether eliminate those inferior ones on the two separate wings of each building. As you can see, I do some sun shadowing simulation here. In summer solstice, at least those west lying location of the less high rooftop top roofs mostly blocked in the morning, while the east lying ones are blocked by the very own buildings in the afternoon session. On the other hand, in the winter solstice, that's more serious. Three other towers, the north-facing portions, would be cast by shadows most of the time from morning to afternoon. I also try to do a comparison between the the horizontal mounting or the angle tilting, and did a bit of study on the optimized separation between two tilted strings of panels. And that's what I come up with in a tabulated data here. Also, it is very, very important to include the systems degradation factor due to the temperature, because from the product specification of the PV panels you can get from the manufacturers, there are some like something like temperature coefficients of power. So in a general sense, the PV system, whatever it is, they degrade over the cell temperature. So as you can see here, the from January to December, in fact, the solar conversion efficiencies is much higher in winter and comparatively low in summer. But also you have to take into consideration the other factors like the climatic factors, the cloudy conditions, the rainy conditions, as well as the electrical losses from all those electronic devices and cables. And the resultant data, the resultant figures I got here is the annual, it is the predicted annual generation of the system in two ways. One in horizontal mounting and the other one with angle tilting. So you can see that specific production here is just about 900, which is barely viable. And this one is about the with the inclusion of all other locations in inferior position. So you can see the comparison between the horizontal mounting and the angle tilting here in this case. The latter one, in fact, has 2.4% more than the horizontal mounting. Also, keep an eye on this column here. This one is about the generation only in July. So you can see the solar conversion efficiencies is almost the lowest one with a moderate level of climatic factor, but it generates the most of the electricity compared to all other months, because that month would have a stronger solar irradiance. So this factor outweighs the all other factors up here. And I will explain more in a minute on the other slides. So so the whole process involved quite a number of rounds back and forth between me and the property management team in discussing the issue. So with their initial material or advertising to the flat owners, they trying to bewither the bewildered us with a very false information that within the 13 years of subsidy from the government, from the utility companies, the overall system performance never degrades over time or across the 13 years. And this is the most agonizing thing I've seen. So I try to argue with them with many evidences and reasons. And they also, but later on, after several rounds of discussion, they gradually reveal a bit more information that contradicts with what they presented initially. Like later on, they supplemented a kind of solar edge simulation study that the resultant electricity generation would only have 66,000 kilowatts per year in year one only, compared to what they are trying to say with the initial material that with 76,000 kilowatts a year all the way for 13 years. So I'm not sure whether it is a very suable lawsuit. I want to make maybe a better later on. I consult Dr. Mandy for that. And here's some of my response to the issue. Yes, as I said, I try to argue with them whether or not they will still insist on this capacity of installation. And in the midway through, they try to grow another project, recent project, with an electricity bill only in July, that they with this installed capacity of almost 10 kilowatts, they've got some $5,500 rebatement from the utility company. Then I immediately struck back to say that you can't just show this the best month of the year performance to infer the whole system's annualized performance. This is a very misleading point here. And then with that, I also try to persuade them not to go for those extra 1/4 of the areas in the inferior positions, because even if they equip with the module level power optimizers as they claim, the resultant payback is getting worse in the end. So here are I try to persuade them with the financial figures. Well, first of all, with the optimal settings of 44 kilowatts hour, which is downsized by 1/4 of the claim. The financial model is pretty quite promising. The MPV values are positive. There's payback period, be it the simple way or discounted payback way, within 10 years. That's within the all 13 years of the subsidy. The IRR is close to 10%, which is feasible, very profitable. And in this case, I ignore the installation of power optimizers, because to them it is useless with all the same geographical condition, climatic condition. They don't really have to install those power optimizers. So in the second case, I try to incorporate the power optimizer as well for this reduced size of PV installation. But this is a fairly meaningless comparison because they with the same amount of power energy generated, is only the inclusion of the power optimizers will only jack up the cost and resulting in a longer payback period. But still, in this case, all the figures here are almost positive. And in this case, the third one, with the almost full capacity they wish to install, without the power optimizer, still the annual electricity generation can be obtained a bit more than the case with the reduced size, because as you can see in the top right-hand corner, the photos here, which some of the wings PV panels can still be functional in their separate like morning hours or afternoon hours, along with the rest of the major areas here. So I assume in this calculation that at least half of its generation can be harnessed out by this overall system to the grid. With the inclusion of power optimizers in the fourth case here, eventually all of the electricity generated from these panels at the inferior locations can be harnessed out. But you can see the financial figures here are all the way inferior, all the way less advantaged. Particularly if you look at the MPV, the discounted payback, they are all negative. So the help from the power optimizers is not quite significant. We'll compare it to the very worst case here in the third one. So a big question to the project design team, whether they should really consider to include all power optimizers for all the panels if they wish to increase 1/3 or 1/4 more areas at the disadvantaged locations. So case sharing overseas. Obviously, they are more concerned with with other consideration factors like design and O&M. So they would try to imply more analytics, gauging factors in the TNC process or the system performance tests. Like in this case, they focus more on the performance ratio, the annualized generation by a number of various formulae. And most notably, they also would include the penalty bonus mechanism to penalize or reward the contractor, the operator, if they can perform up to the level they guarantee on day one. So there are many documents and design process they have to go through with the project investors. So here comes my final part of the talk. In the future process for Hong Kong, the current feed-in tariff scheme would definitely favor the application, especially to the household, the the rooftop applications in residential buildings. But yeah, the more sensible mind is demanded from the whole process, from planning, design, and construction, operation, and so on. Building facades integrated with BIPV, with crystalline silicon or other thin film technologies, there is quite a potential. And there's also room for utility scales projects considered in Hong Kong, but they should be best propelled by utility companies and government. Like floating PV system, for example, currently there are two cases on trial in water supplies department here. I think one at Shepik Reservoir and one at the Ploverkov Reservoir. And furthermore, some offshore or Atlantic wind farms could be considered in Hong Kong. That could avoid potential environmental issues to the neighborhoods, as well as the surrounding ecosystem, I believe. Some biomass processing plants or waste treatment plants here, like the one at the T Park in Tuen Mun West. And as for the grid parity in Hong Kong, I could say or foresee that it's quite a long road down the path, because we usually encounter resistance from the general public or even within the utility companies that they may not increase their electricity tariff gradually year after year. But to really achieve that grid parity, in the case of Hong Kong, it's very much depends on the further costing down of the upstream renewable energy industries. That is the procurement price, the all the way down, cost it down, so that the grid parity becomes achievable to Hong Kong. And I try to quote a very outdated graphs here from the Deutsche Bank on the US grid market, because in 2006, that was a time before the financial tsunami across the world. At that time, the whole solar PV industry was living at the fondest moment, and they try to make a prediction around 2013 that the US market alone could reach the grid parity. But in fact, up till now, the whole wish was still behind the progress, because that involves quite a lot of states or federal policies, and some of the states can already achieve the grid parity, some do not. So still 1 or 2 more years time to come in order to achieve the whole grid parity across the US. So still a long way to go for the case of Hong Kong, and I hope that the no carbon targets set by China or by Hong Kong especially the case to achieve the 2030 or 2050s targets. Could be realizable in the end. So that's all for my presentation. Thank you.
Thank you, Javier, for oh, I don't need to be there. I should go there too. But then I don't have a chance to spread out, right? All the questions I have. But anyway, I would take this chance while they are setting up the Q&A section to ask everybody to give all three of our speakers a round of applause. And for some of you on the online audience, I apologize again for a short period of technical difficulty that we have. We will have 2 more seminars under the Energy Efficiency Forum. One of them will be at the end of September, and then another one at the end of October. The date hasn't exactly set yet, but we will we will announce it soon enough. And for our audience here, if you're interested, please stay tuned. The questions from the online audience can be posted on the Zoom chat, and then the chat moderator will send it to me so that the panel or the three speaker can answer those questions. Some of you might have a request the PPT. We would check with the speakers, and to the extent that the thing is appropriate, we will make it available to you. So just let us know either through the chat here or through some other mechanism, emails or whatnot. Let us know. We'll try to do our best to accommodate your requirement. And I also, just before the Q&A, I want to thank our consultant, Rob Chen, who have done a very good job in setting up the physical venue and the online system. And most of all, I want to thank all the participants, speakers, as well as the audience. I hope I will have a chance to see you all in the future as well. I have 3 questions here from the online podium, from the online audience. And the first one is that, I guess this must be for Javier. It says, as solar and wind power plants occupy a lot of land, will the growth of solar and wind power plants be decreasing or become more expensive in terms of opportunity cost and competitiveness for land use in Hong Kong?
As I said in the very last session of my talk, the opportunity costs very much depends on the scale you want to invest in projects and the intended locations in Hong Kong. I know wind farms in Hong Kong are hard to hard to be realized. It's very much depends on the utility companies and the government's effort. But I would believe that they would roll out some more favorable policies to make it happen. As for the solar PV, I would say, well, also depends on the scale of application. So because right now with the gross feed-in tariff scheme, so all of the potential residential premises would do the investments on their own because of that incentive. But for a utility scale projects, it also down to the wish of the government and the utility companies, because land areas is so valuable in Hong Kong. So as I said in the slides, maybe some other areas like the floating PV solar on reservoirs on the oceans, for example, have to be driven by the government and the utility companies.
Okay, I got here a question for Dr. Chai. We all know that when China decided to comply with Chairman Xi's pledge at the UN conference, there will be a great cost to China in order to meet its worldwide carbon change obligation. We saw your presentation today. Indeed, that it shows the good thing is that it shows that China is seriously intended to comply with its promises. But on the other hand, many of us are also concerned what the actual cost will be in terms of the price the industry and the manufacturing particular sector and the power generation sector have to bear. So Dr. Chai, can you comment on whether there's any overall estimate in terms of the impact on economic growth for China with or without having to meet this climate change commitment? Dr. Chai, do you get the question? Next question. Okay. Well, the next question is what is the potential of offshore wind power plant in China? In particular, use of offshore wind power to produce hydrogen. Jiawei, you want to answer that? And then I will go to Dr. Chai as well.
I'm not sure if this question is suitable for Hong Kong or the rest of China. But the hydrogen storage, well, in the case of Hong Kong, it's more applicable to the utility scale projects because those generations from the households, as I've explained in the scheme, are all fed into the grid, but they are so relatively small in the amount compared to the massive amount of electricity generated from the power plant. So the demand side management, or the control between the supply and demand is fairly easy and absorbable. So there is no need to include any storage like hydrogen or battery for the cases of household applications. But in the case of utility scale projects, where the demand side management really matters, then they can start to think about such application just right next to their installation area to store up parts of the electricity generated. So then they can later on at the right moment to release the store energy back to the grid. So yeah, that's my opinion, I would say.
Dr. Chai, you want to add to that answer, and also as well comment on the first question that we have?
Could you hear me?
Yes, we can hear you now.
Okay, great. The network seems not stable. Yes, obviously, actually, because China have a big stock, actually high carbon stock sets. So the transition in China is not so easy. And also due to the different developing stage, actually, compared to the industry countries, lots of problems. For example, we just mentioned in my presentation, for example, the installed power power capacity. For example, the coal-fired power capacity. For example, in the EU and in the United States, most of the coal-fired power cities installed in the 1970s. Till now, it's already worked for like 40 or 15 years. So it's already at a retired stage. But in China, it's different. It's only 10 or 15 years old. So the problem here in China is totally different. And as you know, China's energy resources, for example, for energy security issues, major oil or natural gases should be imported from other countries. So the problem here is it's very seriously, and also such kind of transition will bring a cost. Just as we mentioned, annually investment is about 3.5 trillion RMB annually. It's almost about 70 million US dollar.
Dr. Chai, do you have any estimate on the economic impact, for example, for the plan that you presented earlier today? We lost the connection again. Okay, let me move on to a question with Professor Fang. We all know that the famous President Trump took the US out of the WTO, and does Biden now reverse that and come back to WTO? And did he come back to WTO with a mindset that the US want to dictate what goes on with WTO? Or will the regional and bilateral agreement that now have set up during the past 4 years, while Trump was creating all kind of trouble or trade war, not only with China, but also with the US allies, be the norm of the future?
Thank you, Chairman, for your great questions. So I will address them one by one. First, we all know that Trump is very anti-globalization. He doesn't believe in multilateralism. He thinks so badly of the World Trade Organization. And also he took the US out from the Paris Agreement. Thankfully, he didn't have the time to get US entirely out of the WTO. Even he made this as his campaign promise, but he didn't succeed in the end. However, he did successfully block the appointment of the appellate body members, which is kind of like the Supreme Court at the WTO. So in the past 1 to 2 years, unfortunately, we didn't have a functioning appellate body at the WTO adjudicating cases. So that was one of the big problems that make WTO in the crisis. So since Biden took the presidency, we did observe a few positive trends, such as Biden no longer blocked the appointment of the new DG, is an African lady. So finally, we now have a new DG. Otherwise, without a DG, without the head of the WTO, you can just imagine the chaos. So that is one positive step. And some commentators also predict that Biden is likely to bring the appellate body back to life by appointing new appellate body members so that we could have a properly functioning dispute settlement, which is regarded as a crown jewel of the WTO. But I guess more months still are required for us to observe what will take place. But I must say that I'm now more positive than before, more optimistic than before. And at the same time, as the chairman correctly pointed out, is with the WTO on the crisis, we have on the other hand the emergence of bilateral and the regional trade agreements, like the RCEP earlier concluded the world's largest regional trade agreements, including China and ASEAN countries. So yeah, I mean, if the WTO keeps not moving forward, then the alternatives will have to come up, like what we are witnessing. But right now, I think I still put quite some faith in the WTO. I hope it can be revived. It can be moving forward, just perhaps under a different path or whatsoever. But I think this is a multilateral trading system that can done a lot of contribution to the whole world. Yeah, thank you.
Thank you. I think one of our audience here, Dominic, have a question also.
Yeah, my first question to Professor Fong. Now, starting from 1975, I was helping Taiwan to fight against ITC in America. You know, at that time was GATT, G-A-T-T, and then you have Kennedy round, Uruguay round, Tokyo round, etc. Before they have WTA. But this is very, very difficult because China and Taiwan at that time, they called them a non-market economy. So even right now, they use the same strategy. So it is contradictory for free trade and international protectionism. But I saw your final recommendations. I do not think the central government understand all your recommendations. I do not think. Therefore, I personally believe we should form a think tank outside of China, because I heard from She Keyuan, they said Xi Jinping has got 24 think tanks, all in China, none of them in overseas. So Hong Kong is part of China, one country, two systems. We believe we should unite not only Hong Kong, Macau, but all the overseas Chinese all over the world to to establish a think tank and give construction opinions to central government. If you individuals say, I'm a professor, I give you some proposal, they will throw it in the wastebasket. But if you have a very strong team and work together with the media, then it will be useful. This will apply also to Mr. Tsai and also to Mr. Yip. Because, very simple, I've been doing performance contracts for so many years, but failed. You know why? Because the customer never believe you. You have to pay first. And after they have thousands of reasons that they don't pay you back. Those are the problem. So we must have very strong think tank to support this and influence the government to adopt our policy. Same thing to carbon neutral. I worry very much about 2060. This is why I focus on hydrogen economy and circular economy, as well as nuclear, but UNDP does not support me for nuclear. So for the last few days, I was talking to Finland, but never mind. What I'm trying to say is we should all unite together to solve all these problems. Because we have the seminars today, tomorrow, here and there, nobody's going to listen to us. It will be only our internal talks. So we must build up something very strong, very influential, which I call it four wheels drive. Four wheels means the government, the NGO, and finish. NGO, the question is very simple. Do you agree with me? That's the question. It's very simple. I'm raising something, and do you agree with me? That's the only question. So the four-wheel drive means the government, you have to convince the government. If the government don't move, nothing will happen. Not only in Hong Kong, in China, but elsewhere. So the four-wheel drive finish and the government, the NGOs, the entrepreneurs, and the media. Thank you.
I can chime in a bit with my previous experience or views. Well, for example, in the case of European unions, they set a 2020 targets back, I think 20 years ago. They set a target by 2020, they would have electricity generation from the renewable energy systems accounting for more than 20% of the whole, all across Europe. But in the end, only a few countries in the EU, like Germany, Northern Europe, and some in Central Europe, or even not in the UK, they were in the end far behind the target. So yeah, I understand why, because even the most advanced civilization or society like the European Union, they are in fact all scattered around with many countries plotting by themselves, not really following the unanimous targets or goals in the end. So yeah, I understand your concern. But yeah, I think with the recent urgency of the tackling the climatic issues, I think, well, at least I believe that the most humans will be driven into more and more into the practice for the betterment of the future.
Okay, I'll just give some brief.
I think it's good. Yeah, I just give a brief reply. I totally agree with you that the policy recommendations are kind of like my wishful thinkings. I don't have too much hope that in the near future that the Chinese government will totally change the state capitalism to a free market, to a market-oriented system. So that would be probably a long-term plan. But on the other hand, I do think the government, I do think some parts of them realize that we need to be a bit more market oriented, like the market to play the decisive role instead of the government picking the winners or government decide which companies to support. And in the low carbon energy sector, actually, I think if you look at the solar PV in China, all the dominant firms, they are private firms. None of them is SOE, none of them is joint venture. So that's promising phenomenon to observe. And same with the NEV, we also have a few private companies that are really doing well at this moment. So to that extent, I think although the party control is pervasive in China, there is still room for private firms, private economy to grow. So let's hope that this momentum can be there for them for a long time in the future. Yeah, thank you.
Dr. Chai, can you hear us? Oh, we lost that, huh? Okay. Yeah, but in any case, I think that as China moving up, right, to the leading position as the US have been for the last 50 years, China probably should also be aware that you cannot have all the cakes and eat it yourself. You need to spread it out, right? And the US doing that by freeing up, the production of the lower value added category of goods and services to China in particular, right? But also to other developing countries as well, and open up, i.e. the US market, so that goods and services can go there. Now the US benefits from it because the standard of living goes up, right? And things are cheaper for everybody. I think China should now also open up its domestic market and be an importer of some of those lower value added food, and then focus its power in manufacturing and its power in decarbonizing, the economy by moving high end. That way, I think the world, on average, hopefully, will be better. Unfortunately, we still have a few questions here, but we are running out of time. So that I would have to, as a moderator, stick to the crop, and that I will try to pass those questions on to the speaker, and maybe they can provide some answers, which we will post it in our HAESCO website. And for those who have not visited them, I would encourage to do so, because we are upgrading, right? We have not finished the work yet. It's still work in progress, but we are upgrading our website and make it more informative and make it updated more frequently, and also maybe even more interactive, right? If we can do that, so that we would, post some of the feature or some of the PPT if we get permission from the speakers on our website as well. Okay, with that, thanks to all in participating, and we'll see you at the next seminar. Bye-bye.